Yesterday, one of the strongest storms on Earth struck American territory. Today, the clouds are finally clearing, and the first satellite images coming back are revealing something that meteorologists couldn't fully see while the storm itself was still sitting on top of it. For nearly 2 days, everything anyone knew about what Bavi was doing to the Mariana Islands came from models, radar loops, and infrared cloud top temperatures. Educated estimates of a storm too dangerous for anyone to fly through or walk out into. Now the storm has moved on, the sky has opened up, and for the first time since Sunday, it's possible to actually look at the ground. What that first look is showing isn't just damage, it's a set of questions about why one island came through this so much worse than its neighbors sitting less than 50 miles away, about whether this storm quietly did something no typhoon has done to this island chain before, and about whether the forecasters chasing this thing for 4 straight days actually got it right, or got surprised at the very end. So what exactly are scientists looking for in these first images? Start with the images themselves. They're the reason this story is being told today and not next week. Satellite passes over the Marianas are now coming in clear enough to read the landscape itself, and the landscape has changed. Hillsides that were green 3 days ago now show long brown streaks where wind tore through vegetation. Coastlines look subtly different, scoured by surge and by waves that were still building past 25 feet in the surf zone as the storm's core moved through. Cloud cover that had obscured the islands for the better part of 2 days has thinned enough that analysts can, for the first time, start comparing what's there now to what was there before Sunday. This is normally where a damage documentary would jump straight to numbers. This one can't, not yet, because the more useful comparison, the pixel-by-pixel change detection analysis that turns a satellite pass into an actual damage map, takes days to produce properly, not hours. What the first images do confirm, without needing that analysis, is scale. This wasn't a storm that clipped one corner of one island. The visible disturbance stretches across the entire chain, from Rota in the south to Saipan in the north. A fingerprint roughly 100 miles long, left by a system that was, at the moment it made that fingerprint, arguably close to the strongest a tropical cyclone can physically become in this pocket of ocean. And of every island inside that 100-mile stretch, one shows a mark distinctly deeper than the rest. That's where this story actually starts. Why did one island come away looking so much worse than the other 3? Rota is small even by the standards of the Mariana chain. A single town, a population numbering in the low thousands, an island you could drive the length of in under half an hour. It's also, according to every piece of tracking data collected as the storm approached, the exact spot Bavi's eye chose to cross. And here's the detail that matters more than it sounds like it should. Bavi's eye, at landfall, measured roughly 21 miles across. Rota itself is barely bigger than that. This wasn't an island brushed by the edge of a hurricane's eye wall. This was an island that the eye was, for a period of roughly an hour, large enough to swallow whole, meaning nearly the entire landmass sat simultaneously inside the most violent ring of wind the storm had to offer, rather than experiencing it as a wave that builds, peaks, and passes over a period of hours the way a larger landmass would. It's the same geometry that made 2018's Typhoon U2 so punishing for Tinian and Saipan, when that storm's eye engulfed both islands at once. Rota's mayor's office didn't survive the passage. That came through in the first video to leave the island, filmed once the wind eased enough for anyone to step outside. What that single piece of footage confirms is that the eye's calm, when it finally arrived over Rota, revealed a government building with its roof gone. What it doesn't yet confirm is how much of the rest of the island looks the same way, because as of this recording, nobody has been able to get a full survey team across the island to check. Has Bavi quietly done something no typhoon has done to this island chain before? That single number, 180 miles an hour, measured as the eye crossed Rota, is worth sitting with for a second because of what it's being quietly measured against. In 2018, When U2 tore through Saipan and Tinian at 175 miles an hour, it became the strongest typhoon on record to strike those islands by wind speed, a record that stood for 8 years. Bavi's landfall intensity over Rota came in 5 miles an hour above that. If that number holds up once meteorologists complete their official post-storm analysis, a process called best track review, which typically takes weeks, not days, and reconciles every satellite estimate, buoy reading, and pressure observation into one final figure. Bavi would not simply be another severe typhoon in a region that sees several a year. It would be the strongest typhoon ever recorded to make a direct landfall anywhere in the Mariana Islands. That's not a small claim, and it's exactly why no agency has made it yet. The number stands for now as provisional, real, but not yet stamped as final, and that hesitation says something important about how this science actually works. In a region with no Hurricane Hunter aircraft flying reconnaissance missions the way they do in the Atlantic, every wind estimate for a storm like Bavi comes from interpreting satellite data rather than measuring it directly. And the agencies doing that interpretation know better than anyone how easily a 5-mile-an-hour margin can move once more data comes in. How close did Bavi actually come to the absolute limit of its own strength? There's a second number worth putting next to that one. In the days before landfall, scientists had calculated Bavi's maximum potential intensity, the theoretical ceiling set by the temperature of the ocean underneath it and the air far above it, at somewhere around 200 miles an hour with a central pressure near 885 millibars. Bavi hit Rota at 180 miles an hour and 910 millibars. That means the storm arrived at the islands having used up roughly 9/10 of the absolute maximum strength the atmosphere and ocean were capable of handing it. Storms rarely get that close to their own ceiling before landfall interrupts them. Usually something intervenes first: dry air, a shift in steering winds, an eye wall replacement cycle that doesn't complete in time. Bavi's did complete in time. That's not luck. That's a storm that spent 4 straight days doing almost everything a tropical cyclone can do to maximize its own strength, arriving at the one populated obstacle in its path at nearly the exact moment it was as strong as physics would allow it to be. Which raises the obvious next question. Did the forecasters see this coming, or did Bavi manage to surprise the very people who'd been tracking it around the clock? The honest answer is a little of both, and the split is revealing. On the storm's track, the forecasters were remarkably close to right days out. The official guidance had been narrowing in on a path very near Rota for nearly 48 hours before landfall, and that's almost exactly where the eye went. Track forecasting for this storm, in other words, worked about as well as track forecasting for a Category 5 typhoon can be expected to work. Intensity was the harder problem. The official guidance issued in the day before landfall had Bavi arriving at the islands somewhere between 165 and, in the most aggressive re-intensification scenario, 174 miles an hour. Bavi came in at 180, past the top of even the optimistic version of that forecast. That gap, 6 miles an hour beyond the best-case scenario forecasters had modeled, is where Bavi genuinely surprised the people studying it. It's a reminder that meteorologists have always said, publicly and consistently through this event, that their confidence in this storm's track was higher than their confidence in its exact peak strength. And Bavi's final approach is exactly the kind of case that explains why that gap in confidence exists at all. If Guam never took a direct hit from the eye, why did it still go dark, shut down its port, and lock down its main airbase? While the eye was doing that to Rota, the rest of the chain was absorbing a different version of the same storm. Guam sat close enough to the track to take the dangerous inner edge of Bavi's wind field without ever getting the eye's brief lull at the center. Arguably the more grinding experience for a populated area, hours of sustained destructive wind with no pause built in. To the north, Tinian and Saipan caught the storm's other flank as it widened during its eye wall replacement cycle, a process that, by design, spreads a storm's most dangerous winds across a broader area, even as the single strongest gust near the center can briefly ease. That's the geometry behind why 4 islands sitting within roughly 50 miles of each other are, right now, reporting 4 different pictures of damage. It also explains something in the confirmed infrastructure toll that might otherwise look strange. The Port Authority of Guam suspended all operations. Andersen Air Force Base restricted its gates to essential personnel only. Guam's Naval Hospital canceled outpatient care through Tuesday, keeping capacity clear rather than risk it. Officials said dozens of schools and medical facilities across the territory were likely affected by wind and flooding, though it's worth being precise about that word, likely, because it describes an expectation based on the storm's measured path and strength, not yet a completed inspection. None of that list describes total destruction. It describes a heavily built, partially hardened territory that absorbed the edge of the storm's core rather than its absolute center, the exact opposite of what happened 40 miles away on Rota. Why does one building survive a storm like this while the one next door doesn't survive at all? It isn't randomness. Guam's military infrastructure and its larger public buildings are built to reinforced concrete standards shaped by decades of typhoon exposure, the same design logic that lets Andersen Air Force Base restrict access rather than evacuate outright, and that let the Naval Hospital simply pause elective care rather than shut its doors. Older residential construction across the territory, and especially across the smaller islands of the Commonwealth, tells a different story. Homes built with lightweight metal roofing and wood framing, common across the Pacific for reasons of cost and availability, perform predictably worse against sustained winds above 150 miles an hour because the failure point for that kind of roof isn't the wind pushing on it. It's the wind getting underneath it once a single panel lifts. Once that happens, a roof doesn't damage gradually. It comes off. That's the same failure mode that turned Rota's mayor's office from an intact government building into the image that made it into the first video out of the island. And it's almost certainly the same failure mode playing out right now in homes across all 4 populated islands that haven't been reached by a survey team yet. Did Guam need a direct hit from the eye to suffer this much coastal disruption? This isn't the island's first lesson in what a major typhoon does to its shoreline. In May 2023, Typhoon Mawar struck Guam directly as a Category 4, pushing a storm surge of up to 14 feet and dropping over a foot of rain across the island. At the time, the strongest typhoon to hit Guam since Pongsona back in 2002. Bavi never gave Guam quite that direct a hit. The eye passed to the north over Rota rather than over Guam itself, but the coastal forecast issued ahead of landfall had still called for inundation, approaching 15 feet near the storm center, storm surge up to 4 feet with additional wave run up on top of it, and breaking surf building past 35 feet in the surf zone, numbers that, if they held anywhere close to forecast, would put this event in the same range as Mawar for coastal impact, on an island that took the edge of the wind field rather than its center. That's the pattern that makes this stretch of the Pacific so difficult to plan around. A storm doesn't need to hit an island directly to inflict a direct hit's worth of coastal damage if the island happens to sit inside the surge and swell radius of a system this large. Whether Guam's shoreline actually took Mawar-level punishment this time is one more answer that depends on ground teams reaching the coast, not on the forecast that preceded them. Why were officials already bracing for something worse than the wind speed numbers alone suggested? The human response to all of this had actually begun before the storm ever arrived, shaped by a fact that makes this whole event heavier than the wind speed numbers alone convey. As many as 1,300 families across the northern Marianas were still living in tents when Bavi's warnings went out, displaced by Sinlaku, the super typhoon that struck the same islands less than 3 months earlier and never fully finished being cleaned up. Shelters on Saipan and Tinian opened earlier than usual, specifically to give those already displaced families more time to move a second time in 1 year. By the time Bavi's outer bands reached the chain, some of those shelters were already full, turning newer arrivals away. Rear Admiral Josh Lasky's Joint Task Force Micronesia stood ready throughout to support civil authorities if requested, and the U.S. Coast Guard pulled its own cutters out of the water rather than risk them in seas that were pushing past 40 feet near the storm's core, repositioning them to return the moment conditions allow, to start reopening ports and clearing waterways for the recovery effort that hasn't started yet. Guam's governor said she would begin her own on-the-ground damage assessment early Tuesday morning, walking the island herself to see what days of preparation had actually held up against. As of this recording, that assessment is happening in real time. No deaths have been officially confirmed. Officials said their goal going into landfall was 0 fatalities, and right now, that goal appears to be holding, but appears to be holding is not the same sentence as confirmed, and won't become the same sentence until search and damage crews finish reaching every part of every island. So what happens next, both to the storm and to the islands it just left? Bavi didn't dissipate once it cleared the Marianas. By Monday evening, it had pulled roughly 150 miles northwest of Guam, still moving at a walking pace, still carrying 165-mile-an-hour winds into open ocean. What finally starts working against it is wind shear, forecast to sharpen considerably over the following days. The same atmospheric force that, arriving even 12 hours earlier, might have blunted Bavi's landfall entirely. Current guidance has the storm weakening to a still major Category 4 as it crosses open water, dropping to Category 3 strength by around Friday, July 10th, as it approaches Japan's Ryukyu Islands and northern Taiwan, before curving toward the Chinese coast south of Shanghai the day after. For the Marianas themselves, the more immediate risk isn't the storm anymore. It's what the storm left behind. Rainfall across the chain had already reached somewhere between 8 and 15 inches by Monday evening, with more expected through Tuesday night, falling onto ground already saturated from an unusually active year. Flash flooding and mudslides remain a live hazard for at least another full day after the wind itself has moved on, which is part of why officials were still telling residents late Monday to stay off the roads even as the sky began to clear. Is what just happened here a freak event or part of something bigger? Step back from Rota, from Guam, from this 100-mile fingerprint across the Pacific, and a harder pattern starts to show through. Bavi is the third Category 5 tropical cyclone the planet has produced in 2026. It's the second super typhoon to strike this exact stretch of American territory inside of 3 months, landing on islands that hadn't finished repairing themselves from the first one. Sinlaku, in April, caused more than $1.5 billion in damage to these same islands, and was itself the 10th Category 4 or stronger storm to make landfall on U.S. territory in the past decade. As many major landfalls on American soil in 10 years as the country had absorbed across the entire 57 years before that. Layer Bavi on top of that count, and this single stretch of a few thousand square miles of ocean has now taken 2 of the strongest tropical cyclones on Earth within a single year. Warmer oceans don't just make storms like this more frequent. They raise the ceiling Bavi was chasing in the first place. The maximum potential intensity that let this storm get within 9/10 of its theoretical limit before it ever reached land. A warmer western Pacific doesn't guarantee a repeat of what just happened to Rota. It does mean the ceiling keeps climbing on the same water, above the same islands, for whatever storm forms there next. The full picture of what Bavi did to the Marianas is still being written, island by island, by survey teams who are only now able to reach the places satellite images can only hint at. But the 2 numbers already on the table, 180 miles an hour crossing an island barely wider than the eye that carried it, and a storm that used nearly everything the atmosphere had to give before it ever touched land, point to a question this one storm can't answer by itself. How much stronger can a system like this get on this same patch of ocean before something like Rota simply isn't rare anymore?